Welcome back. In this video, we will be discussing mass to mole to particle conversions. Using the sample size in grams of any particle, element, molecule, or ion, we can determine how many moles of that particle exist in the sample and how many individual particles exist in the sample. Previously, we learned that we can convert between the units using an appropriate conversion factor. We can convert between numbers of atoms, ions, molecules, etc., and moles using Avogadro's number. We can also convert between moles of an element and mass in grams using the element's average atomic mass, or molar mass, in units of grams per mole. For example, how many atoms of sodium exist in a 3.57 gram sample? Well, we know that sodium has an average atomic mass of 22.99 grams per mole. We can convert the mass of the sodium sample into moles by dividing the sample mass by the average atomic mass. When we do this, you'll divide and get an answer of 0.155 moles of sodium. You will notice that the gram units of sodium cancel, leaving only the mole unit. Also, significant figure rules for multiplication and division were followed, resulting in an answer with 3 significant figures. The next step in the problem is to convert the sample of sodium from moles into individual numbers of atoms. This is done by multiplying the number of moles with Avogadro's number. You will notice that the mole unit cancels out, leaving only the atoms unit. Also, again, when we solve for our answer, we followed our significant figures rules once again for a total answer of 9.35 times 10 to the 22 atoms of sodium. This type of problem can be done going in the opposite direction. For example, what is the mass in kilograms of a sample of silver iodide containing 8.42 times 10 to the 25 formula units? Let's figure out what steps we need to do. First, we know the identity of the substance is silver iodide. According to our naming rules, the formula is AgI. Next, we need to convert the number of formula units into moles using Avogadro's number. Remember, Avogadro's number is 6.022 times 10 to the 23 of anything per mole. We need to convert the moles into mass using silver iodide's molar mass. We can calculate the molar mass by adding the average atomic mass of 1 silver with that of 1 iodine. The molar mass of AgI is 234.77 grams per mole. finally, we need to do a prefix conversion to change the grams into kilograms. Remember, on our prefixes, 1 kilogram is equal to 10 to the third grams. If you notice, each step cancels out our appropriate unit. So formula units of AGI cancel, moles of AGI cancel, and grams of AGI cancel, leaving us only the units of kilograms of AGI. When we plug these multiplication and division steps into our calculator, we follow our significant figure rules and find that our sample is 32.8 kilograms of silver iodide. This process can be used throughout the semester